So we're jumping to 4.7. 4.4, 4.5, and 4.6, maybe, I don't know. But at least 4.4 and 4.5. After we get through the bulk of chapter 4 and we take a test on chapter 4, then 4.4 and 4.5 are looking at graphs of sine, cosine, and trig, or sine, cosine, and tangent. So we're going to go back and learn how to graph them separately. So I'm just trying to do the other main parts of chapter 4. And so that takes us to lesson 4.7, which is inverse trig functions. Now, ironically enough, I don't know if you guys remember doing just inverse functions in Algebra 2. My Algebra 2 classes have that as part of their current chapter. You guys remember anything about inverse functions? In order to find the inverse, we would take the x value and the y value and switch them. Okay, that's what inverse functions are, is you take the x and the y and you switch them. So you're taking your input and your output and you're switching. Well, that's what we're talking about here, okay? These inverse trig functions take your input and your output and you switch them. So normally, like on that chart over there, when we do, say, the sine of 30 degrees, your input is your 30 degrees, your angle. The output is the numerical value of 1/2. Inverse sine flips those. Okay, so we're going to talk about all three, but we're going to start with sine and focus there. Inverse sine function. Now, you'll see it written two different ways. Right there, sine inverse x. Okay, the sine inverse function has the -1, kind of like an exponent, but it's right in between the sine and the x. Okay, so that's one way that you'll see inverse sine function. The other way you often see it is seeing arc sine x. Okay, arc sine is another way to say sine inverse. So those are equivalent. You'll see them both in homework. Don't let them freak you out. Okay. Now, the idea is the domain of the inverse sine function is -1 to 1. So you see all those charts there, or all those values that are normally our outputs? Well, now they're the inputs. So all values inside the inverse sine function will be between -1 and 1. Okay, and keep in mind when we talk domain, we are talking the x values. The range, so range of course being y, the range of the inverse sine function is -π/2 to +π/2. So all of your outputs, your answers, must lie within this range. And we're going to talk a little bit because we can't just use any angle. It has to be in this range. Okay? Notice what it says here. The answer to an inverse sine function is an angle. Normally the angle is input. For inverse sine function, the angle is our answer. Okay? And thus we have inverse sine. Okay. Now, this example that talks about, example 1 is find the exact value of each of the following without a calculator. First of all, anytime they say exact value, I never want a big, long, messy decimal that you've rounded. That's not exact, okay? Now, obviously, if the answer is 1.5 and it's just that, okay, yeah, that's exact, but exact is never a big, long, messy decimal. Notice, this is how do we do this without a calculator? So, the idea, sine inverse of 1/2 is equal to what? Well, I'm going to hint at the chart. Sine inverse of 1/2 is equal to what? Now, first of all, I got to get my habits here. Always check, because I like to throw in sticklers. Is 1/2, this is our input, is this an appropriate domain value? What is my domain of the inverse sine function allowed to be? -1 to 1. Is 1/2 appropriate?
Yeah.
Yeah, that's between -1 and 1. Okay, so always check that, just saying. Sine inverse of 1/2. Basically, you're asking yourself, the sine of what angle is equal to 1/2?
Pi over 6.
Okay, how do you get pi over 6? Do we see it? Here's 1/2 in the sign column, yes? At what angle is that happening? Pi over 6. And I will say, if you tell me 30 degrees, okay, I get it, but with these inverse trig functions, they usually want us to talk radians. Okay, so I am going to be looking for pi over 6. Now, with that in mind, is pi over 6 an appropriate range value? That's the other thing you always want to check. In other words, is it between negative pi over 2 and positive pi over 2?
Yeah.
And it is, because 1/6 is less than 1/2, right? If you kick the pi out of there, that's what you're thinking. Okay, guys, so your answer here is pi over 6. Okay?
So we're basically just finding the range for all these?
Yeah, you're finding the output, which is your range, but you're finding your angle. Okay, now there's going to be some catches, but basically if you want, what did we do? We said sine of what angle equals 1/2, right? That's basically what we did on this problem, is sine of what angle equals 1/2. Now, before I move on to part B, you have, on the back of your notes, you have some half circles on the back of this page of notes, yes? So if you look at the back of your page real quick, you have some half circles, okay? And what this page is these are a physical graph or a visual display of your range values. Okay, these, and this is good. Okay, these graphs will help it make sense when we get into the trickier problems. But what it is these represent where your answers could fall. Okay, where your answers could be. Now, visualize. I know you guys know where pi over 2 is, right? Pi over 2 is up here. Negative pi over 2. So to get to positive pi over 2, you go up and counterclockwise. How do we get to negative pi over 2? You go down and clockwise, right? So right there, anything between negative pi over 2 and positive pi over 2 are allowed answers. Or in other words, what's pi over 2 in degrees? That is what?
90.
90. So basically, any answer between negative 90 degrees and positive 90 degrees is an allowed answer. Okay? Okay. Now, we already talked about that first answer being pi over 6, and it's right there. Okay? I wanted to point this out to you so you can be familiar with it. Now, shall we go back to example B? Because, of course, example A was the piece of cake example, right? After that, we have to get a little more difficult. Okay? So B, sine inverse of negative square root of 3 over 2. So first of all, get in that habit, is it an appropriate domain value?
No. Oh, wait. Yeah. Square root of 3 over, I was thinking 3 over 2.
And I know you guys don't necessarily have your calculator in front of you. Square root of 3 is 1.7 divided by 2,
So, yeah.
0.866. Is this an acceptable domain value?
Mm-hmm.
Yeah, because it's between negative 1 and positive 1. Okay? Again, I'm warning you now, always check.
So what do we put if it's not just undefined?
We'll talk about it when we get there. Okay? Now, as you look at this, my recommendation is forget the negative for right now. Because do we have any negatives on that chart? We don't have any negatives on our chart over there, do we? So I would just stop and think, sine of what angle is equal to square root of 3 over 2?
Uh, 6 years. 5 6.
You guys with them? Okay, and again, I said forget the negative for a moment, because we're going to talk about how to deal with it. But the sine of pi over 3 is equal to square root of 3 over 2. So what that tells me is my answer is going to be some variation of pi over 3. And actually, maybe I shouldn't write that right there quite yet, but pi over 3 is up in quadrant 1, yes? Here's the deal. This is talking about where sine is negative. Well, I'm not allowed any answers over here in quadrants 2 or 3. Sine is positive in quadrant 1. So what do we have to use to get a negative sine value here? We're going to have to use the equivalent angle down here. So what is equivalent to pi over 3, but down in quadrant 4? Thoughts?
Would just be 4 pi over.
No, because 4 pi over 3 is going to be over in quadrant 3.
Yeah.
So keeping in mind, it has to be something up in quadrant 1 or 2. There's the quadrant 1 angle. What's the equivalent down there in quadrant 4? It is the negative version of the angle. So negative pi over 3. Okay. So we'll talk on tomorrow when we get to cosine. We'll have to talk differently. Because cosine has a different twist. But sine. Basically, if it's a quadrant 1, it's a positive angle, you're going to use the positive. If you have a negative domain, it's going to be down here in quadrant 4. And it's just going to be the negative. Now, if someone tries to tell me 5 pi over 3, is that in the same spot as 5 pi over 3? Think about it. If you go back to your original unit circle, okay? Remember, all these angles have multiple names, right? So pi over 3 is up here. If I go down here on my normal unit circle, it doesn't say negative pi over 3, does it? It says 5 pi over 3, correct?
Mm-hmm.
Okay, so that's the equivalent angle with the same reference angle down below, but 5 pi over 3 is not in my range. And so that's why we have to use the negative pi over 3. Okay, so for our answer on this problem, we're looking at negative pi over 3. Okay, and as I said, with sine, it is a pretty quick and easy, okay, quadrant 1 is the positive, quadrant 4 is the negative varieties of them. Okay. Is this an acceptable range value?
Yeah.
And it is. We already checked that. Okay. Questions I can answer there?
Yeah.
Okay.
How is it acceptable? Isn't it?
It was in between the negative pi over 2.
Because negative pi over 3 is in
I'm
between.
looking at 1 and 1. Yeah.
Okay.
Gotcha.
And it wouldn't quite, yeah, no. You were looking at domain instead of range. Fair enough. Okay. C. The sine inverse of pi over 2. Now, did you catch what they're doing there?
That's a 90-degree angle.
But is it an angle? Where are my angles supposed to be here? With sine inverse, my angles are supposed to be where? They're supposed to be the answers. This is supposed to be my input or my domain. What kind of domain am I supposed to have? A number between -1 and 1? Okay, folks, this pi over 2 is not an angle. It's a number. Okay, so when you need to check and see, is that in the appropriate domain? It's not an angle, it's a number.
No, it wouldn't be, because it'd be like 1 point something.
5 something.
Yeah.
1.57, I believe.
Yeah.
Okay,
Yeah.
so this is not an angle, it's a number. If you check out pi divided by 2, it's 1.57. Okay. And so the idea here, pi over 2, 1.57, I don't know, I want to say 1.5, it doesn't matter. What do we know about that number? 1.57 is,
Outside the -1 and 1.
yeah, it's outside the -1 and 1. It is greater than 1. So here's the deal. This answer does not exist. Okay.
Can't it say like no answer or something?
Does not exist as official lingo. Okay. And in case you need more clues to write down your paper, I'm going to say because outside of domain. Okay. So right there is why we always check. Is our given x value, our domain value, does it fit in the domain? Or are they trying to be trickery? Okay. We'll talk about when we get down to example 2 how to put these types of problems into the calculator, and you would get an error on the calculator in this scenario. Okay? And I guess we'll stop there. We will pick back up after our quiz tomorrow.